everyone. So we're going to continue our discussion of factoring, in particular factoring through grouping, while focusing on polynomials where that leading term isn't 1. Now, if you remember, when we factor trinomials, we use the AM method, but one of the stipulations was the leading term had to be equal to 1. Well, now we're going to actually do a method that's very similar to the AM method, but a little bit more general, something that we can use when that leading term is some number other than 1. Pretty much, it's actually a combination of the grouping method and the AM method. So let's look at this trinomial right quick. Now remember, for the grouping method, we need 4 terms in order to actually do it so that we can create 2 binomials and do greatest common factor. Here we have a trinomial, so the goal is to somehow make this into a 4-term polynomial. Now the first thing that we do, just like we always do, is to factor out using greatest common factor. Look at all these terms, see what number, the biggest number that they can all be divided by. All these are able to be divided by -4. So our greatest common factor is going to be -4. So we divide a -4 from here, a -4 from here, and a -4 from here. Remember, greatest common factor could also be variables, but these don't all share a common variable. So we pull up the -4, and then what we're left with is 2x squared minus 15x plus 7. So now we're down to our polynomial again. Now, this is where we kind of do a little bit like what we did with the AM method. Remember, the AM method was find 2 numbers that multiply to the last term and add to the middle term. So we're going to take that and tweak it a little bit. Instead of just finding numbers that multiply to this term, first we actually want to multiply the 2 and the 7, the first term and the last term. So when we multiply 2 and 7, we get 14. So this is the number that we're looking for that multiplies to this and adds to the middle number. So this is where we're getting that number. So we're not just looking at the last term, we actually have to multiply the first and last and then use that to see what numbers multiply to this and add to this. So again, we know that the number that we're looking for is 14. So numbers that multiply to 14 and add to -15. Well, there's a whole bunch. Since this is a negative number, that means I'm going to have both my numbers being negative. So -1 and -14, -2 and -7, and that's pretty much it. So if I add these first ones, I get -15, and this is -9. So the 2 numbers that I'm going to use are -1 and -14. So again, it's very similar to the AM method. Now here's where we make it a little bit different, because remember, the whole point is we're going to end up factoring by grouping. But in order to do that, we need to have 4 terms. So what we're going to do is we're going to actually replace the -15 with these 2 numbers. So my original polynomial was 2x squared minus 15x plus 7. Now I'm going to rewrite it so it's 2x squared minus 1x minus 14x plus 7. So that's kind of why I want these numbers to add up to this middle number, is so that I can split it up into 2 pieces. That way I can now factor by grouping, because I'll now have 4 terms. That's the whole point of this. In fact, technically the AM method is just a simplified version of this because this first term is 1. So it's just ends up being the last number adding to the first. So when we group the first 2 terms and the last 2 terms, we have this. And then we do our factoring by grouping. Pull out greatest common factor here. The greatest common factor here would be x. And the greatest common factor here would be -7. When we do that, we get x being pulled out, leaves us with 2x minus 1. And when we pull out the -7, we get 2x minus 1. Again, just like with the factoring by grouping from before, This is how I know I'm on the right track, when these two terms are the same. So now what I do is I pull out a 2x minus 1 from both terms, and I just write the x minus 7 in its own set of parentheses. So negative 4, remember this whole negative 4 that we pulled out in the beginning stays there the whole time. The 2x minus 1 that we had in both of these terms, and then the x minus 7 that were left over. All right. And then, like always, our very last step in all these is just check to see if we could factor one more time. Every now and then it happens where we get to the final ending and maybe we have to factor using greatest common factor or using dots or something like that. All right, so let's do a few practice questions. Oh, this is a mistake. I believe that's supposed to be a 3. All right, so pause the video, work on stuff, and we'll go over it in a second. All right, so starting with number 1. We can't pull out an n. There's no greatest common factor, so I can actually just start off with the process. Take the first and last terms. 2 times negative 7 is negative 14. So two numbers that multiply to negative 14 and add to negative 13. Again, it's actually so here, because I want a negative number, only one of my numbers is negative. So I could have negative 1 and positive 14, 1 and negative 14, 2 and negative 7, negative 2 and positive 7. Now, one of the tricks I told you was that if this middle number is negative, that means the bigger number is negative. So that means I can actually cross out these two because the bigger number was positive in them. But I add these, and let's see, what do I get? When I do 1 plus negative 14, I get negative 13. 2 plus negative 7 gets me negative 5. So that means my two numbers are 1 and negative 14. So I'm going to rewrite the polynomial, 2n squared, because that stays the same. I'm going to replace this middle term with plus 1 minus 1 plus 1n minus 14n, and then that last term carries down. Remember, we're just deleting this middle part and putting in 1n plus negative 14n. Then we group and factor. So there can be an n pulled out of both of those terms. And another negative 7 that can be pulled out of those two terms. And my final factoring will be the 2n plus 1 that they both share. Remember, I only write it one time. And then an n minus 7. The n minus 7. And this is my answer. Coming over to here. So if I look at here, there's no coefficient I could pull out, but they all share an x. So I'm going to pull out an x right from the get-go. And I'm left with 3x squared plus 11x minus 4. All right, from here, I'm going to take these two terms, multiply them, and I get 3 times negative 4, which is negative 12. So two numbers that add to negative 12 and, multiply negative 12 and add to positive 11. So it could be negative 1 and positive 12, negative 2 and positive 6, negative 3 and positive 4. Notice I'm not doing the negative of these because, again, this is a positive number, so my bigger number is positive. So negative 1 plus 12 is plus 11. This would be just plus 4, and this will be plus 1. So these are not my numbers. So now my polynomial turns into x, 3x squared, replacing the 11x with minus 1x plus 12x. I apologize for that. I don't know why that's happening. minus 4. All right, once I get to here, now I'm going to group and factor. Now, remember, if you don't get the same term, what that might mean is that you might want to switch the terms. You might want to switch which one goes first and which goes last. It shouldn't matter. You should end up getting the same answer, but just in case, try that. And if that doesn't work, that just means you might have to recheck the numbers you used. So from the 3x squared and the 1x, I can pull out another x. So let me just write it like this, x, which leaves me as 3x minus 1. And then from here, I could pull out a 4, which leaves me with 3x minus 1. So my final answer is the x from before, the 3x minus 1 that they both share, and then I'm just going to put the two terms from in front, the x and the positive 4. And this is my final answer. Again, I didn't want to do a double check. Can I factor this any further? No, so I'm good. All right, here are the next two. Pause video, work itself, and we'll go over in a second. All right, so looking at this, again, greatest common factor. I can factor something out. In fact, the greatest factor is a 3. So this becomes 3 2x squared plus 5x minus 7. From here, multiply 2 and negative 7, and we end up getting negative 14. So when we look at these numbers, we want two numbers that multiply to negative 14 add to positive 15. So that would be negative 1 and 14, negative 2 and 7, and that's it. So negative 1 plus 14 is 13, and negative 2 plus 7 is positive 5. So my two numbers that I'm going to replace the 5x with is negative 2 plus 7. So this new polynomial becomes 2x squared. Remember, don't do anything different with that. Minus 2x plus 7x minus 7. All right. So from here, I'm going to group them. So 2x squared minus 2x. Clearly, I'm going to be able to pull out a 2x from that, and I'll be left with an x minus 1. And from here, I could pull out a 7, and I'll be left with another x minus 1. So my final factor will be 3 from before, the x minus 1 that they both share, and the 2x plus 7 that are in front of them. Can I factor any more? No. All right, down here, looking at these numbers right off the bat, it's very clear that none of these numbers can be factored anymore, because 7 is a prime number. So we take the 8 and the 7, multiply them, and what we end up getting is 56. So because of the fact that the middle number is a negative, that means both of my numbers will actually have to be negative in order to get a positive number. So negative 1 and negative 56, negative 2 and negative 28. So just going through all the factors, the next one will end up being negative 4 and negative 14. And the last one should be negative 7 and negative 8. So going through all these, we can already say this would be negative 15, this would be negative 18, this would be negative 30, and this will be negative 57. So my two numbers are going to be the negative 1 and negative 56. So rewriting this will be 8b squared minus 1b minus 56b plus 7. All right. So grouping these two, let's see. This one I could pull out a b from both terms. So I end up with 8b minus 1. And from here, I'm going to be able to pull out a negative 7. I'll be left with an 8b over here and a negative 1 over here, because this will be negative 7 divided by b divided by b, and I'll be left with the 8b minus 1 that they both share and the b minus 7 on the other side. All right? And that's pretty much it. So you're going to keep practicing this. We'll do another 2, and that'll be pretty much it. So pause the video, work on yourself, and we'll go over it in a second. All right. So once again, can we factor using greatest common factor? And the answer is yes. The biggest number looks like it's going to be 2. So just divide all these terms by 2. I get 4x squared over here plus 21x plus 5. Multiply the 4 and the 5, and I get 20. All the factors that multiply to 20 and add to 21. So 1 and 20, 2 and 10, 4 and 5. This equals 21. This is 12. This is 9. So my two numbers will be 1 and 20. So my new polynomial is 2 times 4x squared plus 1 x plus 20x plus 5. Group them. So first 2, last 2. 2 stays there. I could pull out an x from both of these terms, and I'm left with 4x plus 1. Over here, I end up pulling out a 5 from both terms, and I'm left with 5 times 20 divided by 5 is 4x plus 1. Then rewriting, we have the 2 from before, the 4x plus 1 that both terms share, and the x from over here, and the plus 5 from over there. And there we go. Remember, we always end up with this same type of answer of 2 binomials being multiplied. All right, coming down here. So here I can actually have a few greatest common factors. I'm going to definitely have an x term that I could divide out. And it looks like I can pretty much only divide out a 2. Let me just quickly double check. Yeah. 2, 2, 2. All right. So when I divide by 2x, I end up getting 7x squared. 146 divided by 2 is plus 73x, and 60 divided by 2 is plus 30. All right, multiply the first and last terms. So 7 times 30 is 210. So again, a lot of numbers that can actually multiply this. So 1 times 210. You can also have 2 times 105. I can already tell that these two are definitely not it. So then we could also have 3 and 70. And let's see. We can have 5 and 42. We could have 6 and 35. We can keep going, but we can already see the number that it's going to be used, 7 and 3, because 3 plus 70 is 73. So these are the numbers that I'm going to replace it. So now it becomes 2x, 7x squared, plus 70x, plus 3x, plus 30. Now you may notice I kind of switched it. Normally I do the smaller and then the bigger, but I like this symmetry. So 7 and 70, 3 and 30 makes me realize that I'm definitely going to end up getting the right response. So that's what I'm going to do. Here I can pull out a 7x from both terms. So I end up getting 7x. This becomes x, and this is plus 10. From over here, I could pull out a 3 from both terms. And I'm left with x plus 10. So my final answer is the 2x that I pulled out before, the x plus 10 that they both share, and the 7x plus 3 that was in the front. And that's that. All right. So hopefully that makes sense. If you need help, let me know. These are the 3 questions, so you can pause the video and answer these. And we'll end up going over this stuff. There's going to be another video that's pretty much the same thing, so we'll get a little bit more practice. Again, if you have any questions, let me know. Send me an email or a message on mine. Come to Extra Help. Otherwise, good luck, and I'll see you later.